Hey everybody, Mr. Judson here. So today we want to graph the greatest integer function. And this is something we haven't done before, so we don't really even know what it looks like. So today it's really important that we start with the parent function. Y equals greatest integer function of x. And a lot of times this thing is referred to as a step function because it looks like a set of stairs. Okay, it's a step function. And so what we want to do is we want to see why does it look like a set of steps. So what I'm going to do is I'm going to start off by making an XY table. I'm going to plug some numbers in, kind of like we did back in Algebra 1. And then as I do that, I'm going to draw a graph of what this looks like. Alright, so first of all, if I plug a number in like 0, the greatest integer less than or equal to it is 0. It's equal, okay? And if I go to 0.1, the greatest integer less than or equal to that is 0, or 0.2, 0, or 0.5, 0, 0.9, 0. But once I get to 1, the greatest integer less than or equal to that is 1. So what I'm doing is I'm jumping from 0 up to 1. So if I plot all these points, here's 0, 0, and then 0.1, 0, 0.2, 0, 0.5, 0, 0.9, 0. But then at 1, I jump up to this spot right here. And so what I have is, I got all these dots here. What it does is it makes a step, and then I go up to the next step. So if x equals 1.1, the greatest integer is 1. 1.2, 1. 1.5, 1. 1.9, still 1. But then at 2, we jump up to the number 2. And so I've got another step right here. 2.2, what's the greatest integer? 2, 2.5, 2, 2.7, 2, 2.8, 2. So everywhere in here, all these decimal numbers, when I plug it into this greatest integer function, what I get for a y value is just 2. And the pattern continues this way as well. Let me go back and erase. All right, so let's go in the negative direction. Let's say I've got negative 0.1. or negative 0.2, or negative 0.5, or negative 0.9. Now we got to think of the number line. Here's 0, here's negative 1. A negative 0.1 is right about here somewhere. So the greatest integer less than or equal to that is negative 1. Negative 0.2, okay, back a little farther. Still, the greatest integer less than or equal to that is negative 1. For all these, it's going to be negative 1. When I get to negative 1, the greatest integer less than or equal to that is still negative 1. But once I go to negative 1.1, now the greatest integer less than or equal to that, I got to go to the next spot, negative 2. Okay? So I can see that those steps will still go down in the negative direction. If I plot this point, negative 0.1, comma, negative 1. Let's get a tick mark in there. That'd be right about here. And then when I get negative 0.2, still negative 1, negative 0.5, still negative 1, negative 0.9, still negative 1, negative 1, we're still at negative 1. But then when I go to negative 1.1, I drop down here to 2. And so what we see is this thing that just looks like these stairs that go on forever. Now, we got to talk about one more thing here. You guys remember the vertical line test? You can only touch one point at a time. Well, I don't want to touch a point here and up here at the same time. So what we do is we put open circles on the right side of each of these steps so that our vertical line test can still be true. if I'm right here on the y-axis, I'm not hitting this point and this one at the same time. I can only hit one, right? Otherwise it's not a function. So there it is, there's my steps. And just so that we can see this on our graphing calculator, all right, so what I'm going to do is I'm going to graph the parent function just to make sure everything looks right. So I'm going to go to y equals. Now, we don't have a way to do these kind of weird brackets here. We have to actually use a word kind of like we did with absolute value. We had to use ABS for absolute value. I need to use INT for greatest integer function. And so if I hit this math menu and I go over to the num menu, num stands for number. We've got different types of numbers. We've got absolute value. If you look at option 5 here, we've got the integer, which means the greatest integer function. Okay, that's how they abbreviated it here. So I'm going to hit option 5, and I'll put an X in there. And this is how I would graph the parent function for our greatest integer function. Now, one thing that's a little bit different here is this actually looks like a staircase, right? But on this, it doesn't. We're not seeing this part right here, you know, the back side of each step, the vertical part. And that's, again, because of that vertical line test, we shouldn't see it. Now, our calculator, it really shouldn't show that, but in reality, it's doing what we tell it to do. If I go to the mode button here, see right here where it says connected? What that means is, as our calculator plots points, it tries to connect them all. So if I'm doing a parabola and it gets a point here, 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 and so on, it then goes back and tries to connect all those points because we're in connected mode. All right? What it's doing with a step function is it's taking the bottom part of one step and it's trying to connect it to the top part of the next, and that's why I get that vertical line on my calculator. I don't think that your guys' calculator shows that. I think the programmers at Texas Instrument figured out how to solve that problem, and so now when you guys graph it, you won't see that up and down line. So we just need to know that when you look at my graph, that's not supposed to be there. It's just the way the program was made. Okay? All right. So one thing we know about steps is sometimes you go up steps and the distance that you step up is not very small or very large. It's small, which is kind of awkward to walk up those kind of stairs. Sometimes the step is huge, and that's also kind of awkward. My cabin at Lake Cushman, I need to get up the stairs to a loft in a short distance of time, so I had to make those steps pretty tall and small at the same time. Some steps are wider than others. And so how do we know that stuff? How do we figure that out? Is it possible to go down the stairs? Right? So here are the rules that we want to make sure we understand. So rule number 1. If A is less than 0. Now think about this. What has that done so far? It flipped the parabola upside down. It flipped the absolute value upside down. It flipped the square root function over. Same thing's going to happen here. It's going to flip this over, and if that happens, then our stairs will go down like this. We're now walking down the stairs instead of up the stairs. The circle at the end will still be in the same spot. If B is negative, so that means B is less than 0. So if I saw a negative number right here, that means we're flipping across the y-axis. So when you flip this across the y-axis, that means that open circle is going to flip to the other side. All these stairs will flip over here, these stairs will flip over, so I'll be going down the steps again, but it's also going to flip the open circle to the other side. So this will also look like we're going down the steps, but open circle now on the left side. Now, one thing that's really important, we've got to have somewhere to start. Like, where do I begin my steps at? And so a starting point Remember how I told you there's always this one point that's really important? And it's always negative c over b comma d. There's my starting point. So once I have that starting point, if the b value is positive, we go this way and draw the open circle. If the b value is negative, we go to the left and draw the open circle. Okay? What if these are both negative? Well, see, if I flip these stairs down like this, and then I flip those over like this, I'm going up the stairs again. So if both A and B are negative, we're back to this original graph, except for the open circle has flipped to the other side. Okay? Now, I want to make sure we get this part, because this is really important. I'm going to change color here. If b is greater than 0, so b is a positive number, then we're going to start a step, go over a certain distance, and then draw an open circle. Okay? If b is less than 0, so it's negative, then we're going to start a step, go a certain distance, open circle. Okay? We've got to make sure we realize that, because the b value is going to tell us from the starting point, do I go to the right or do I go to the left? The b value tells us that. Okay? I suppose you can even maybe add this. We're going that direction if b is positive. We're going this direction if b is negative. All right, and then the other piece of information that we need here is this. When you have a set of steps, there's a height to those steps, and there's also a width to those steps. How long is each step going to be, and how high do I have to step to get to the next one? All right. This is always found by looking at the a value. We'll do an example of this in a second on the graphing calculator. And this is always found by doing 1 divided by the b value. It's kind of weird. You wouldn't think that you'd have to do 1 divided by something, but that's how it turns out. So let's just kind of play with that for a second and see if that's true. So if I want to put an a value in front of this, I just have to insert it right here. I'm going to insert the number 2. So now I've got 2 times the greatest integer function of x. I've only changed the a value. All right? And I'm going to graph it. And what I can see is that the height of those steps is now 2 units, whatever that a value is. So here's the first step. I'm going up 2 units. There's the next one. Go up 2 units. We'll hit the next one. Okay? If I change that to a 3, whoops, and graph it, now I'm going up 3 units to get to the next step. Okay? So the a value controls how high our steps are. Let's look at the b value. So I'm going to delete this. I'm going to go in here and type 2x. So now my b value is 2. Remember, the b value is inside the greatest integer function. A value is out in front, okay? So my b value is now 2. So if I hit graph, it looks like my steps went like this. They got tiny. Right? So I've only got half of a unit right there for that first step. And then I go up 1 and I got another half unit. If I want to change my window here, let's just go from 0 to 2. And here from 0 to 2. See, there's 1, so I got half a unit. And then I go up 1 and there's another half unit. Go up 1, there's another half unit. Right? Let me get back to my original window here, zoom option 4. All right, so I know how to figure out how wide the steps are and how high they are. I know how to figure out which end of the step the circle is on, depending on whether b is positive or negative. And I also know how to find my starting point. There's one more piece here that probably isn't crucial to graphing this, but it's something that we could pay attention to. If I took a board and I laid it across the front of all these steps, let's just say we had some kind of a 2x4 here, okay? The slope of that board is going to equal a times the b value. Okay, just like in our absolute value function. A times b gave you the slope of those straight lines. Well, if I laid a 2x4 on the front edge of the steps, that would be a straight line, and it has a slope associated with it, and it's exactly the same as with our absolute value function. You know, so if you think about it, if a and b are both negative, a negative times a negative is positive, that gives us that positive slope. If one of these is negative and the other is positive, well then we get a negative slope. Okay? All right, let's graph a problem. All right, so we'll do this first one together, and then I'll get if you guys want to try on your own. All right, so when I look at this, a and b are both positive. That means positive times positive is a positive slope, so my steps need to go like this. Okay? My starting point is at 3, 1. Remember, we're doing negative c, so opposite of this, divided by the b value. So there's 3 over 1. Okay? My height for each step is going to be 2 units, that's the a value. And the width is going to be 1 divided by b. So 1 divided by 1 is 1. And since b is positive, it means from my starting point, I want to go this direction and then do an open circle. Okay, so I know what the steps look like, I know what the height and the width are, I know where to start, and then I can go ahead and draw that open circle in there. So let me get a graph. Don't forget, these pictures are on my classroom webpage, under graph paper at the very bottom. You print this out, you've got six graphs. You don't have to worry about drawing this. Plus, this is the same thing that's going to show up on our exam when you have to graph things. So if you just get used to it, it's like, boom, there you go. I mean, I think you should be fine either way, but you know, anything you can do to make it a little bit easier or make life easier, I think is a good thing. All right, so I'm going to start at 3, 1, which is right here. I should draw my step 1 unit, that's the width, and then do my open circle. So there's my first step. Then my height is going to be 2 units, so from there I should go up 2 units and draw the next step. And then go up 2 more and draw the next step. And so these steps are going to kind of go down as you go from right to left. So there'll be a step right here, and right here. And one of the most common questions I get asked here is, how many steps do we have to draw? And I say, you know, draw enough so we know what's happening. You should always draw at least 4. But if you can fit a few more in there, go ahead and draw them. It doesn't take long, right? I already knew the distance down was 2 units. I just had to go draw another one and then do a circle. Draw another one, do a circle. Once you've got the pattern, it's pretty easy to add. I'm not going to add as many as you want. You know, it takes me about 2 seconds per step. That's not a lot of time. Okay? Now, one thing to be careful of, because this happens sometimes. Someone's drawing steps, and they go, okay, I go down 2 units and draw the next one. So there it is, and there it is. And what you notice is there's a gap right here. Someone's walking down these steps, it's like, okay, good, good, boom, good. And then the next step, it's, you know, we just fell through a hole. So you don't want to skip one accidentally. Make sure you get all the steps in there so that they're drawn the right way. So there and there. Don't want anybody falling through a hole. All right, let me give you guys one to try. So remember, it doesn't matter if I say y equals or f of x equals, right? So y equals 1.5 times the greatest integer function of 0.5x plus 1, whoops, I need that double bracket there, and then minus 2. Don't let the decimals scare you guys, they're just numbers, right? Our rules don't change, we still follow the exact same set of rules. You guys go ahead and try it. Alright, so once again, A and B are both positive. That means my steps are going to go like this. I'm going up the stairs as I go left to right. My starting point is going to equal a -1 divided by 0.5. -1 divided by 0.5, that's a -2, comma -2. Okay, and my height for these steps is going to be 1.5 units. We can handle that, that's not bad. And our width is going to be 1 divided by b, which 1 divided by 0.5 is still 2. So I've got a width of 2 and a height of 1.5 units. So let's draw a picture of that. Starting at -2 comma -2. There's where I begin. And I'm going uphill, so and my b value is positive, so I'm going to draw my first step that direction and then put the open circle on. And I want to go 2 units. So to right there. Now I got to go up 1.5 units. So that would be to right here and go across and another open circle. And then go up another 1.5 units, open circle. And then another 1.5, there it is. I've drawn 4 steps. If you want to quit right there, you can. I know some people like to go ahead and fill up the space. So here's another one. And here's another one. That didn't take me that long to do that. All right, let's try one more. Alright, so we've got f of x equals 3 times the greatest integer function of 1 minus x minus 1. Now remember, if you don't like the way it looks, if you don't like the way I wrote this, write it in a way that you feel comfortable with. You guys go ahead and try it. Alright, so I don't like the way it's written. I'm going to rewrite it. I would rather see this as 3 times the greatest integer function of a -x plus 1. Okay, that's just where the x was. We have a times the greatest integer function of bx plus c plus a d value. Okay, I don't care if we're subtracting out here, I'm still going to call it plus a d value. Alright, so because b is negative, that means we're flipping across the y-axis, and our steps are going to go downhill this time. Also because b is negative, when we have our starting point, we're going to go to the left and then put our open circle on there. So I just want to be aware of that. So our starting point, that's going to equal a -1 divided by a -1, which is +1, comma -1. Okay, remember we're doing -c over b. So a -1 divided by a -1 gives us that +1. Height equals the a value, that's 3. And the width, 1 divided by 1, so it's going to be 1 unit. But because b is negative, I just want to make sure, remind myself I'm going to the left from my starting point. Alright, so 1 comma -1. There's my starting point. I'm going to go to the left 1 unit and then draw my open circle. Steps need to look like this. and so my height is going to be 3 units. So I have to go up 1, 2, 3, and now I draw my next step. 1, 2, 3, now I draw my next step. Okay, that got a little too big. If I go down 3 here, and then the next one's going to go off the grid. There it is. Now remember, you can check these with your graphing calculator. If I go back and I graph this function, so let me just clear that off. I've got 3 times the greatest integer function, which is under the num menu. I've got 1 minus x. And even though I don't like to write it this way, I'm going back to the original function. Just want to make sure that my picture matches that original equation. Minus 1. Okay, and I hit graph. Now, the calculator isn't going to show us where the open circles go. Right? It's not going to draw that picture for us. What I do see is I've got a step right here at 1, -1, and it goes to the left, and there should be an open circle right there. So if I hit the trace button, see, there's that step. What I want to see is when I get to 0, I'm bumping up to this step. So watch my x values here as I arrow over. There's 0.6, 0.5, 0.4, 3, 2, 0.1, and now the next time I hit the arrow, this arrow button, I'm going to go over to 0. And see what the cursor did? The cursor jumped up to the next step. That means there's an open circle here, and we're jumping up to the front edge of that step. Okay? I also didn't talk about the slope as I was doing this, but let's just do that real quick. So the slope equals a times the b value. 3 times a -1, that's -3 over 1. That means I'm going down 3 units and over 1 to get to that front edge of the step. Down 3 and over 1. Okay? If I go back and look at this one, here my slope is 3/2 times 1/2. Which is 3/4. So pick any point you want. If you go up 1, 2, 3 and over 1, 2, 3, 4, I hit the front edge of a step again. I started here. There's the front edge. If I lay my 2x4 down, I'm still hitting this point right here, right? So our slope does work for this graph. And it should work for all of them. All right, that is what we have for today. I'm going to take those dots back off. So let me get you guys a homework assignment. All right, so here's our homework assignment. Today we're graphing the greatest integer function. We've got 10 equations. Remember I told you guys I'm going to keep on throwing in things that we've already done. So there's an absolute value and a square root. We've got a couple parabolas here where we have to complete the square. All right, so we're getting review over the other basic functions that we've already talked about. So go ahead and take a picture of this now if you want, or remember it's going to be on my classroom webpage. I'll have it there as well. Or you can run the video again and pause it right here. Write them all down. Okay? All right, that's all I have for today. You guys take care. Stay safe.